You cannot outsource accountability for secure software. You can delegate coding. You can delegate testing. You can delegate tooling, but you cannot delegate responsibility for risk. If your organization builds, configures, integrates, or customizes software in any form, you are in the software business. And that means your secure software development life cycle, your secure SDLC, is not a technical choice, it is a leadership obligation. This lecture is about what you, as a leader or architect, must demand from your secure SDLC to ensure resilience, compliance, and long-term business protection. Many executives assume SDLC is an engineering methodology. Agile, Scrum, DevOps, Safe, Waterfall. But secure SDLC is not about methodology. It is about risk governance embedded into software creation. Every new feature introduces potential attack surface. Every integration introduces potential trust relationships. Every cloud deployment introduces identity and configuration exposure. If you do not demand security expectations at each stage of the life cycle, you create invisible risk accumulation. Secure SDLC ensures that risk is identified early, treated deliberately, and measured continuously. Without leadership demand, secure SDLC becomes optional, and optional security is ineffective security. Most security failures originate in design, not in code. When applications are architected without threat modeling, identity clarity, data classification, and trust boundary understanding, no amount of scanning will fix structural weaknesses. As a leader, you must demand threat modeling for critical systems, clear definition of sensitive data flows, defined authentication and authorization models, least privilege principles embedded in architecture, secure API design standards. You do not need to conduct the threat model yourself, but you must ensure that it happens and that findings influence design decisions. Secure design is exponentially cheaper than post-production remediation. Security must be part of requirements, not an afterthought. If product owners define functional requirements without security criteria, engineering teams optimize only for functionality. You should require that every significant feature includes security acceptance criteria, data handling expectations, logging and monitoring requirements, regulatory alignment considerations. When security is written into requirements, it becomes part of delivery definition. When security is implied but not formalized, it becomes negotiable under delivery pressure. You do not need to write secure code, but you must ensure standards exist. Secure coding standards provide consistency. They reduce ambiguity. They guide developers toward safe implementation patterns. As a leader, demand organization-wide secure coding guidelines, mandatory training for developers, defined patterns for input validation, error handling, and authentication, clear secrets management practices, prohibition of hard-coded credentials. Inconsistent coding practices lead to inconsistent risk exposure. Standardization is not bureaucracy, it is risk containment. Manual security review does not scale in modern development. You must require automated validation embedded into pipelines. That includes static code analysis, dependency vulnerability scanning, infrastructure as code scanning, container image validation, secret detection. Automation ensures consistency. It reduces reliance on individual diligence. It provides measurable visibility. But automation must align to risk thresholds. For example, if critical vulnerabilities are detected, is release automatically blocked? Or is it left to discretion? Your policies must define enforcement boundaries. Security without enforcement becomes advisory. Modern applications depend heavily on open source libraries and third-party components. If you cannot see your dependency landscape, you cannot manage its risk. As an executive, you must demand Software Bill of Materials (SBOM) generation for critical applications. Defined remediation timelines for high-risk dependencies. Verification of artifact integrity. Controls over external package sources. Supply chain attacks exploit trust relationships. Without governance, your software inherits unknown risk. Visibility is the first step toward control. Development environments often become blind spots. Overprivileged access, shared credentials, excessive administrative rights, weak separation between test and production. You must demand role-based access controls across repositories and pipelines. Multi-factor authentication for privileged access. Segregation of duties between development and production. Auditable access management processes. Compromise of a development pipeline can be as damaging as compromise of production. Secure SDLC includes secure development infrastructure. If an incident occurs, can you trace who committed a change? What dependencies were included? Which environment was affected? What version was deployed? Traceability is essential for accountability and incident response. Your secure SDLC must require immutable build logs, version-controlled infrastructure definitions, change management visibility, deployment traceability records. Without traceability, investigations become guesswork. Guesswork increases recovery time, and recovery time increases business impact. Secure SDLC extends beyond source code. You must require dynamic testing for exposed applications, API security validation, penetration testing for high-risk systems, configuration review of cloud resources, runtime security validation. Do not assume that code-level scanning is sufficient. Risk exists in architecture, configuration, identity models, and third-party integrations. A holistic view of testing reduces blind spots. There will be situations where vulnerabilities cannot be remediated immediately. What matters is not zero risk. What matters is controlled risk. You must establish formal risk acceptance processes, executive visibility for high-risk exceptions, define timelines for remediation, clear documentation of compensating controls. If developers can override security findings without oversight, your secure SDLC collapses under pressure. Governance ensures transparency in trade-offs. In regulated industries, secure SDLC supports compliance obligations. Frameworks often require secure development practices, vulnerability management, access control enforcement, logging and monitoring, change management documentation. If your SDLC does not align to compliance expectations, audits become painful exercises in reconstruction. When security is embedded from design to deployment, audit evidence becomes a byproduct, not a scramble. Compliance should validate your discipline, not drive it. If you are serious about secure SDLC, you must monitor performance. Key metrics include percentage of applications with threat models, average time to remediate critical vulnerabilities, percentage of builds passing security gates, number of privileged access exceptions, dependency risk trends over time, security defect leakage into production. These metrics should be visible at leadership dashboards. If secure SDLC performance is invisible, it is vulnerable to erosion. One of the greatest risks is turning secure SDLC into a checklist exercise. If teams perform threat modeling mechanically, ignore findings, or treat scanning tools as compliance rituals, risk remains unchanged. Secure SDLC must influence behavior and decision making. Encourage discussions around why this vulnerability exists, what architectural weakness allowed it, how similar patterns can be prevented, what systemic improvements are required. Mature organizations focus on root causes, not surface findings. Secure SDLC only works when accountability is shared. Developers must feel responsible for secure implementation. Architects must feel responsible for secure design. Security teams must act as enablers, not auditors alone. Executives must reinforce expectations consistently. When secure development becomes professional pride rather than compliance obligation, resilience increases naturally. Leadership tone determines whether security is feared, ignored, or embraced. When secure SDLC is weak, you experience repeated vulnerability findings, delayed product releases due to late security discovery, incident response fatigue, erosion of customer trust, regulatory scrutiny, increased insurance premiums. Reactive security is always more expensive than preventive governance. Investing in secure SDLC is not overhead. It is risk stabilization. In a mature organization, security requirements are defined alongside business requirements. Threat modeling influences architecture decisions. Automated security checks are mandatory and enforced. Risk acceptance is transparent and documented. Leadership reviews security metrics regularly. Developers are trained and empowered to code securely. Compliance evidence is generated organically through disciplined processes. Secure SDLC becomes part of engineering excellence, and excellence compounds over time. Ask yourself, can you describe your secure SDLC clearly? Is it consistently applied across teams? Are risk decisions visible at executive level? Do architecture reviews include security by default? Are vulnerabilities discovered early or late? Is secure development treated as quality or as overhead? Honest answers reveal maturity level, and maturity determines resilience. If this lecture has reinforced the importance of secure SDLC, take immediate action. Review your current development lifecycle. Identify gaps in design governance, automated validation, supply chain visibility, and risk acceptance processes. Align security requirements with business objectives. Ensure that secure SDLC metrics are visible at leadership dashboards. Do not wait for an incident to justify investment. If you found this session valuable, subscribe to the DevSecOps for Leaders playlist like this video so it reaches more leaders and architects, and share your thoughts in the comments. What challenges are you facing in implementing a secure SDLC in your organization? In the next lecture, you will explore supply chain security and software integrity, and why they are now board level concerns.